Oh, hello. Welcome to another session of Electronic Assisted Astronomy with an 8-inch Schmidt Cassegrain telescope. So the CPC-800, which I own, is out on the decking, and attached to it is an Altair Astro 294C colour camera, as per usual. In fact, it never changes. There's an f6.3 focal reducer on there as well. We're going to observe a few objects tonight. It's August evening. It's a little bit warm. Temperature, well, I'll say a little bit warm. It's 15.9 degrees. And the sensor temperature currently is 18.8. I'm using darks and flats, and we're looking at M17, the Omega Nebula. So let's stack that. So what we'll do is we'll just capture that, and what we're going to use is we're going to use 4-second subs. We're using a gain of 1000. We're not getting enough stars. Don't know what happened there, but we started again, so there we go. Yeah, it sometimes does do that. It's like it doesn't find any stars. I don't know why. Anyway, we're all over the place, so let's automatically do a little bit of jiggery pokery there. We'll wait for a few more frames to come in before we mess around with the colour too much. So we are at an altitude of 22 degrees, so we're a bit down in the murk on the southern horizon, which also is quite close to a light dome for me. But M17, yeah, that's a very good nebula. So it was discovered in 1745, and it's located, as it says up on the screen, 5,500 light years from Earth. Anything else? I was reading from the NASA webpage. Oh, it contains one of our galaxy's youngest star clusters at only 1 million years old. Wow, there's quite a cloud in space, isn't it? So as I said, we're using darks and flats tonight. I did the flats earlier on. The dark is just an old one I was using, so which kind of matched the temperature out there. Let's zoom in a bit. Yeah, that's definitely a nice nebula. So tonight we're using release candidate 3 of SharpCap. We're using the latest beta of AstroPlanner, and we're using the latest beta, another beta first, the latest beta of Stellarium, which was released on the 25th of July, I think. And we're using a new version of my EAA control panel that does a few more things. So it makes my life easier, especially at 2 o'clock in the morning. That's what I was thinking. Wow. There are certainly a very pretty sight. So we're up to 29 frames. We're dithering as well, so we're using the built-in SharpCap dithering. So every 5 frames, I believe, it's 6 frames. Sorry, every 6 frames, it dithers a little bit. It moves the scope a little bit, and that seems to cover up a multitude of problems, if there are any, of course. I can't see any. It also helps, seems, with satellites as well. Even though I have Sigma clipping on as well, I find that with the dithering on, it clears up the satellite trails, of which there seems to be many these days. I still find it hard to believe that, I mean, I've been doing this now for 3 and a bit years, and it still amazes me what you can see, which you couldn't see when I had my eye next to an eyepiece on the same scope. So it's still incredible that what I just see some grey smudginess here. Most probably this is quite a large nebula, so I would have seen some structure, but I wouldn't have seen some colour. There's definitely some different coloration. Hold on, wind shift. Oops, wrong one. Wind shift there. Don't know how to do it. No. Oh, there we go. I was just getting my cursor on. But there's some different coloration around here. If we zoom into 100%, what are we going to... There's 100%. Could have just used Control 1, but some wisps all the way over here as well. The whole field is full of nebulosity, which is quite amazing. Around a bit. Yeah, that's quite impressive. Oh, there's a satellite trail there. Straight across. On cue, was it? Maybe you saw it actually appear. But we'll see if that just disappears. We've been going for 3 minutes, 32 seconds. So I'm using 4 seconds. I used to use a lot longer, but in the summer months I found that the 4 second was good. There were some guys on, or one particular person actually, on Stargazer's Lounge who uses, I think it was 4 or 5 second, and I kind of followed him really, because I think it's right. I was using 15 seconds, and actually it does work on 15, but I was finding this looks pretty good when I'm using 4 second subs. So coming up to 4 minutes. Enhancements. We've got some enhancements on, have we? Yep, so we've got the bilateral filter and we've got an unsharp mask on as well. Let's see if we can stretch the image a little bit more. I think that satellite trail then comes out a bit more. I can change the shape of, is it called the transfer? The yellow line a little bit. I can modify it now and make things a bit darker, which is quite good. And then I can stretch it a bit more. Don't want to do it too much because it's going to show up some noise. Wow, you can start to see these kind of lines of gas coming out of it now. So we're coming up this 4.5 minutes. I never would have seen this visually. Not like this. There's 5 minutes. Let's log that.
Observation form 17 created.
You can still see the satellite trail. It's fading slightly, but it's still there. It will take a few more frames in order to get rid of that. Oh yeah, switch back to Stellarium. Mainly because Stellarium can do this. I can turn on the Deep Sky Survey, or I can turn on a HIPSO, I think it says Pan-STARRS as well, or I can just see the image that we're seeing here. Oh, let's turn on the reticule. Also Stellarium, I don't have to mess around. I don't know if you're aware, obviously the Sky doesn't do an Altair's reticule. It would always align it to an RA deck grid. So, but there was no reason to use the Sky tonight. It hasn't got any features in that I need that Stellarium doesn't, and Stellarium's got this lovely feature where I can bring up the deep sky survey of whatever objects I'm looking at. I think we'll go to 100 frames, just a round number, nothing more associated with that 100, but and then we'll log it again. What we'll do is we'll attach the other image to the original observation log we just created at the 5-minute mark. 2 more frames, and then we'll move on as well, I think. 99 and 100, I take it. Yeah. So let's log that.
Observation for M17 appended.
And what we do now then, we're going to move on to M16. So if I target M16,
Telescope slewing.
and that's the new feature of the control panel. It takes care of setting the profile in SharpCap, and it also slews the telescope.
Slewing completed.
And that apparently is meant to be M16. And I think the best thing to do is we'll just capture that. Let's go straight into capture. Let's sync. Yeah, so we've got a cluster of stars. There's the bright cluster we saw when we were in fine mode, and we had this a minute ago, didn't we, where it was not. Interesting. It seems to be consistent on this candidate 3 where it's not. To be fair, this is the first night I've used release candidate 3. It seems to take 2 stabs at getting things right. I could switch back to candidate 2, which I know does work, but now we know how to work around, that's fine, we'll carry on. So straight away, we come straight to the pillars of creation. Let's zoom straight into 100%, and there they are. Again, we're just using 4 second subs. A gain of 1,000. On the Altair Astro, it goes into this high HCG mode. It's where you get lower read noise, and you get the same number of f-stops back if you want. But that's at 900. But my chip is a 294 chip, and it seems to have a little problem around that area, especially if you start doing flats at 900. So I moved it up to 950, and that seemed to clear it. But just to be sure, I always run it at 1000 now, which if you're a ZWO camera owner, you're going to go, wow, but it's a completely different gain number system. But it's basically just a little bit up from where that crossover is. Wow. So what can we say about the Eagle Nebula then? So, so the pillars of creation, which are these bits here in the image, they're 4 to 5 light years, just 4 to 5 light years. Not much, is it? And the whole nebula, though, spans 70 by 55 light years. And it's 7,000 light years from Earth, which it says up there anyway. Now, where are we now? We are at an altitude of 24 degrees, so we're slightly higher than, well, we're about 2 degrees higher, because M17 was at 21.9. So, yeah, we're still not really up above. To be honest, I don't really mind what altitude if I can see the object, if I can observe it, but 30 degrees low, what should I say, is an air mass of 2, so somewhere above there would be good, and not too high. 70 degrees maybe maximum. Obviously you can go all the way up to the zenith, doesn't matter. It's just you can get a little bit of rotation going on. Not that that particularly bothers me, but it might bother other people. There's some interesting defects on these stars. You see the little lines coming off of them where they're bright. I don't know what that's hitting off of. It's also amazing, isn't it? Look, we've done 34 frames and we can already see this is much clearer now. It's coming out of the background. The noise is reducing. I mean, remember we're zoomed in at 100%. If we go back out, there you go. So now we're out at the full Monty. Let's move in a little bit so we can get more of the nebula in. I think this is one of the largest. Is it one of the largest star-forming regions in the galaxy? Well, that might have been the Omega Nebula. Well, I mean, they're all large star-forming regions. Obviously, a place where our sun formed in a very similar type of nebula all those billions of years ago. Just over 3 minutes now. See, now when we zoom out, we can see where we came from, which was M17. And look how rich, we're down towards the centre of our galaxy now. There's M16, and further down, it's just this huge, rich area of nebula, star clusters, and one very large black hole. That's just another amazing sight. I mean, it's just because that exposes a bit more detail up here. A little clump right there, a little clump of gas. Let's zoom back in again. There's the clump. It's a little dark clump of gas there. Dust. I wonder if there's a star inside forming. I wonder if there's a solar system forming in there. That would be good as well, wouldn't it? Extraordinary. So at 66 frames. We'll log again at 5 minutes. So according to NASA's webpage, it says the Eagle Nebula can be spotted through a small telescope, and is best viewed during July, or August in this particular case. A large telescope and optimal viewing conditions are necessary to resolve the pillars of creation. That's them. Now, I wouldn't call the 8-inch a large telescope. It's larger than a 6-inch. But then again, it's not as large as 11-inch. Yeah. So it's a mid-range telescope, isn't it? An 8-inch. And it's really easy to see. And the reason it's easy to see is because there's a camera there rather than my eye. the longer you leave it, the more the structure comes out, the more the dark nebulosity appears. We're at 100% still on this, so we're at 5 minutes 36. Let's log it.
Observation form 16 created.
Let's see if we can play a little bit more. Let's change that. I'm wondering if there's too much red, I don't know. Balancing the colour. I find balancing the colour quite difficult. I was, to get it so you can see everything. That's what I'm trying to say. See the little details in the cloud. Wow.
Observation for M16 appended.
Okay. Let's leave those nebula alone for a second and head to my favourite open cluster,
Telescope slewing,
which is M11, which is just up the road a bit actually. So if we come out of here, M11,
slewing completed.
M11 is over here. In fact, if we just sync the planetarium to it, there you go. And let's turn off the. There it is, and there it is, right in the centre of our image. Let me just poke that up slightly. So I'm just watching if it's moving. I think we'll just capture that. Now we might have that same problem where it won't detect any alignment stars first of all, but we know how to solve that now. Yeah, I think we are. Look at that. So there is a fault. So if we clear it, look at that. So there's a fault in release candidate 3, or I say that, obviously it's a fairly obvious fault, isn't it? Let me just move down my WHM filter so if things get a little bit dicey, it will get rid of some bad frames. Look how compact M11 is and how rich this star field is around it. I mean, it's just amazing, isn't it? So we're 6,200 light years. So I believe I just have to believe, I can use knowledge of this. So it was discovered by a German astronomer called Gottfried Kirch in 1681, located 6,200 light years from Earth. It's almost, I got that figure from here. It's the most, so of the 26 open clusters in the Messier catalogue, M11 is the most distant that can be seen with the naked eye. The best time to spot it is in August. Containing over 2,900 stars. Wow. And it really is, I love this cluster. There are lots of good clusters, by the way. Open clusters are fantastic, but I say that about everything actually, but they are fantastic. But it's just this. I think it's just where this is set in the Milky Way with the huge number of stars. that are surrounding it, and then there's this bright cluster of 2,900 stars, 6,200 light years from our location. Let's zoom into 100%. We've got some different coloured stars. We've got some orangey red stars, and we've got some whiter, bluer stars. My FWHM readings have gone down. You may notice that from a previous video. I was trying to collimate my scope. I told you it was ridiculous, and I used a tool to do it, and the tool seemed to work okay. And when I looked at one single star and did the defocus bit, it looked really good. But I noticed that my edges, one side of my image, was definitely way out. I was getting little comets and things. And so I used ASTAP, and ASTAP's got a feature in where it kind of gives a contour map of FWHM, and it basically showed that I was completely out. It was in a really funny place. So what I did was I kept on tweaking my collimation while then take another picture, find out where my hole was moving effectively, where my best FWHM was, and I slowly moved everything up and equalized everything out across the plane, and that's definitely improved. I was up at like a 6 or 7 FWHM, and I know that depends upon the seeing conditions as well, but it seemed very consistent. I was definitely way out, so I don't know. Obviously mine's not an edge, mine's not a Celestron 800 edge, where it has got a much flatter field and edge, and I suppose if you could get one star pinpoint, then all the other stars would be pinpointed. But on the CPC-800, I have a feeling we're quite curved. Our focal reducer is obviously one of the cheap focal reducers. Nothing wrong with it; it works. But the edge most probably has the, as they say, the edge. But yeah, it seems happier. It wasn't perfect, but I got bored doing it. It took me 45 minutes just to tweak it and then take the picture and make sure, and sometimes I have to refocus it just to make sure I was on the rate, and obviously realign it. It's a bit of a pain, really. Someone should come up with an automatic way of collimation. We're at 3 minutes anyway. Our 2,900 stars are really shining quite brightly. Let's come back out again so we can see it set. I might just zoom in. See, there's still a bit of distortion here, but that distortion was way up to here. But if I come out of here a bit, it's still in the corners. What's that? 69%. We get rid of some of it. Some of it's still a bit there. It was a much nicer, flatter field than it was before. And it was really bad before, very bad. But I just put up with it, to be honest, because I like observing. And it was but it got in my way, so I had to do something about it. So we're at a height of, we're 32 degrees, so we're just above the 2 air mass line. And when I say 2 air masses, obviously it's equivalent of looking through 2 atmospheres. If we look at the zenith, we're only looking at 1 atmosphere, of course. Let's adjust. Let's darken it up a bit. Let's change the shape. There we go. Pull it out, or we can really stretch it, and then we can see that blue is predominant. We could try and bring down the colour a little bit on this. We were quite high from there, and then we can do that little adjustment to our line, our yellow line. It just tweaks it slightly, and then we can stretch a little bit more, and we can, once I do that, I can see, and it might be quite hard if you're sitting far away, but I can see just these multitudes, these tiny little stars all the way around, stretching into the distance, into the galaxy. So we're at 4 minutes 44. Let's come back out again. So we're going to log that as well. I have to admit, you might see on here there's a little grey box around it. That's because I actually already observed that before I started the video. I'm sorry. I do love M11, and so I had to go across, and I used M11 actually to, to focus on. And I would say the focusing in Release Candidate 3 and Release Candidate 2 seem, I don't know, a bit better. Though again, I could just be lucky with the seeing conditions. So that's 5 minutes 12. Let's log it. Just make sure it's going to do that. There we go. It's taking the picture.
Observation form 11 created.
So that should go to 6 now. There it does. Which I most probably didn't want to do. So I've got on the night, what have we got here? M11 and M11. So what I can do is I can click on those two M11s and I can say merge those selected observations, and it puts them all into one observation. So it's just done that. Right. So we were moving up. So we're moving up from, let's move up then to M27. Oh, I don't really want to rotate it. If I come out to naked eye view, where are we? So we started down here, down over here, sorry, and we've moved up to M11, and now we're going to go all the way up to the dumbbell nebula M27 in Vulpecula. So yeah, let's do that. Let's slew the telescope up. And I've associated another object, so we're going to take a look at an object, and this object came to my attention when I was reading Deep Sky Wonders, which is right here beside me. It's on page 242, and there it is right there. And we're moving up still. So what I'm going to do, I think my telescope, where it's fairly old, is it 14.5 years now? And then I'm going to come back down again. Yeah, let's capture there. So Dumbbell Nebula, 1,200 light years away. Sorry, I was observing mid-July, I think, about the 17th of July, and I always go to, oh, it's done it again, so we know what to do. We have to clear it. Hold on, our FWHM is a bit too high. Let's get that. There we go. Better. Better. Let's make it a bit brighter. So yes, I was observing on the 17th, and I was making a list. I don't know how you guys plan your observations. Sometimes I just wing it. I just go to an object which I know about, I've seen, and then I move on from there. And I just keep on adding objects into AstroPlanner as I go. And sometimes, of course, I use a planetarium program, and I plan the objects I'm going to look around and add them into AstroPlanner. AstroPlanner has a wizard, the sky has a wizard, and of course there are books, and one of the books that I use is Deep Sky Wonders. One, because it's a very pretty book. It's very well laid out, and Sue French did a great job with it. I think these are her tours of the night sky that appeared in the Sky and Telescope, and they're all collected together. And on page 242 it says "Return to the Little Fox," and it had this object called the Goldilocks variable, which is actually V0571 Vulpecula, and it has a strange discovery in that a Czech amateur astronomer was looking at the cover magazine of the cover picture on 2 magazines, and both of these magazines had an image of the Dumbbell Nebula M27 on, and he noticed that one of the stars that was in one of the pictures was missing in the other picture, and it turns out that it is a variable star, and so he discovered it. I mean, very good observational skills, and quite an interesting way of discovering a variable star. But you see, I do like M27 anyway, and that's the reason I visit it quite a lot. Is for EAA, it's big enough, it's bright enough, it's got lots of structure and colour, so it's absolutely ideal for EAA. And I remember looking at it visually again, and it was, I could make out the shape, this kind of dumbbell shape, but it was just a grey dumbbell, and now we've got these colours. Though we are a bit green, I can see on my graph my green has gone way over here. I'm not sure how to, I'm going to put the colour up a little bit actually first. Let me also zoom in. I think this white star here, this is the white dwarf, so this is puffed off. So it was a red giant, and it's puffed off its outer layers. And talking of red giants, that's exactly what the variable star is, the Goldilocks variable star is, or V571 Vulpecula. In fact, let's see where that variable star is. So if I select it, and then I'll just
DSA completed.
So all that does is it takes the coordinates and the name and puts it onto the clipboard, but in deep sky annotation. So if I bring up deep sky annotation and we do a plate solve, I click nearby, and it'll do a plate solve, and there you go. And then I'll paste in my object, and there it is up here. So this is my, I'm already at 100%. Yes, okay. In that case, we'll do some digital zoom, and let's move right the way in, and we should be able to see it. So there we go. So this dot here is the variable star, and it's a Myra type variable. So it's a red giant that's getting bigger and smaller. It's puffing up and going down. And I also think they have this tendency, it depends where the nuclear fusion is going on in terms of when it's puffing up. And so sometimes the light is shifted more to infrared, which means it's dimmer in visual, and sometimes it's shifted more to visual, which means it's brighter, so what we're seeing, and that affects the brightness. So I'm not a variable star observer, but I basically observe anything. But as I said at the beginning, I always use the same equipment. I don't change it. If I'm looking at a planet, the moon, deep space, comets, whatever, it's always the same telescope sat out there. It's always the same camera, because I only have one camera. And I just don't leave the f6.3 focal reducer on, and that's the way I operate. As far as I'm concerned, the camera has just replaced my eye, and I'm sat inside in here in relative comfort. So I don't change anything. Now, but a variable star observer, there is a set way of doing things, because obviously you've got to make it so that when you take, so except magnitude readings of a variable star, that you can make they're comparable with other observers. But my thought is that even though I'd read and thought, okay, I can see how that's done, I just needed to find a trend, because the first question I wanted to know is what part of the light curve are we on with this star right now? Is it increasing in brightness, or is it decreasing in brightness? So I took some measurements. I used ASTAP for that. In fact, what I'm going to do right now is I'm going to log
observation 4VSX63394 created.
So it said it did. I think it put it in M27. It did. So I've taken a picture, and what I'm going to do is I'm going to measure its magnitude, but its magnitude won't be the exact magnitude, because I'm not just using the green channel. I'm just trying to find a trend. And so I started doing this, and let me just see if I can find it. And here it is here. So I started back here on, well actually I started, I think it was on like the 17th or 18th here. And then I realized that I'd observed it several times that month. So I went back and did the same thing and got this kind of scatter plot. And then since then I've been taking images and finding out the magnification. And this is the polynomial trend line, which seems to indicate that it was getting brighter and now is starting to dim off. So what I'm going to do is I'm going to grab that image which I just took. I'm going to put it into ASTAP. Now I use PNG images. They're saved as PNG images, and they're saved because they're not that big. In fact, if I do the properties for this one, he says, how big is that one? Oh, it's 14.2 megs. But if I do a FITS image, then it's bigger, a lot bigger. But the good thing about a FITS image is it's got all the information in about the location and the pixel scaling of the, pixel arc seconds per pixel and stuff like that, which a PNG file doesn't obviously have. A PNG file has things more to do with photography than astronomy. And ASTAP needs to plate solve this, and the problem with that is that ASTAP's not really an all-sky plate solver, so it needs a starting location. Now up here there are two fields, and I can put the RA and declination in for this object, or the developer was very kind. If I double click it, I can just put in the object that I'm looking at. In this case I'm looking at M27, and it automatically fills in the starting location, which gives it a good chance that when I press solve, it does. It solves it in 0.6 seconds, which is really good. So now that I've solved my image, I can do some good things with it. So if I go into Tools and I go to Variable Star Annotation, it will annotate all the variable stars that are in this view. And this is quite good because now I can locate where my variable star is. Excellent. I think it's down here somewhere, and there it is. So it's this one here, V071, and it ranges from 14.4 at highest to 17.5 at its dimmest over a period of 214 days. So now I've found where my variable is. I'm going to clear that, so I clean up the image, go to Tools and Clean Up, and I'm going to measure, well I'm not, but ASTAP is going to measure the magnitude of all these stars. I suppose it must have a list of relative, and it says it is 15.4. So I can now go into my spreadsheet and add in that on the 9th of the 8th at 2023, and I believe I'm using UTC, so it's 2239 I'll put in, that it's still 15.4. It's only been 2 days. So, and there you go. So now I've added another data point into my graph. Not much has changed. Now obviously there's errors. This is not exact because I'm not following standard ways of doing things. I'm just doing this as a project of my own interest. But I thought it was quite interesting. It does seem to suggest that it went through a maximum and is now coming down. But we'll wait and see. And the great thing about M27, and hence this star, is that you can see it throughout the year. You can see it all the way up to early December. So now I'm going to see if I can follow this all the way down to minimum. Oh, one thing about it, it's not associated with M27 whatsoever. M27 is about 1,300 light years away, and it's like 15,700 and something light years. So it must be coming through a hole somewhere in the actual planetary nebula, or there can't be much dust in its way, so you can actually do it. But yeah, so that was just a little project, and it all came about just by reading what Sue French had put in her book, and then realizing that using the equipment that we've got already, we can start measuring it and do a little project over the years. So that's good. So let's go back to the live view. So we're at 5 minutes 40 seconds, and we're at a zoom of 100%. There we go. Sorry, it's getting a bit. Let's come out a little bit. It's still very green. Now this as well, I just cannot get sometimes the colours how I want. And that green seems in some ways to, it's like a green haze. And I appreciate that there are 2 green pixels for every 1 blue and red pixel. We stretched it a bit more. Let me just drop that down. Move it up a bit. But the incredible structure in it is, I mean, it's just fantastic. The colours, the reds, not the greens though. Now you may notice on one of those other desktops I had SIRL. Now I don't process my images normally, and if I do process them, it's a process that, well, it puts shame to the word processing really. It's most probably going to be a 60-second, just make sure everything's a little bit darker and a little bit how I like to see it. But I don't like that green. And the other night I thought, I don't like that green so much, I'll download SIRL and see what I can do about it. So in fact, I'm going to log that on M27 this time, hopefully.
Observation form 27 created.
Excellent. So what I'm going to do is I'll go back to my SIRL, because I was thinking that just like if I was at the telescope and I wanted to see some more detail, I'd pull out my eyepiece and I'd put my O3 filter on, or my ultra high contrast filter. I'd start to put it back into my telescope, of course, and then I'd breathe on it and all the usual things which happen when you're visual observing. But basically I would enhance the view with filters. So I just thought, why can't I use a digital filter? So I noticed that in SIRL they had this thing that said remove green noise, and if I apply, yeah, it gets rid of that annoying green noise, which I didn't like. So if I now save that onto the desktop, SIRL takes a long time to save. There you go, it's done. So let's bring up the original. Oh, he says, let's bring up the original. Why can't I bring up the original? I thought I was... Oh, is it always going to put that onto the... Aha. Ah. There we go. That was a bit of a palaver, wasn't it? I suggest that's the other one's going to be like that as well. Oh, it's not going to let me grab it when I do it. Oh well, we'll grab it up there then. I'm just trying to compare it. Wow, it's difficult to do it. So that's the original image, and this, well, how do you move in, no idea. Let's go to the desktop and bring that up. There you go. That was easier. So we're at 49%, 49%. Let's go to 100%. You see, I like the blue image better. And the reason I like the blue image better is because I find the green doesn't have the contrast. So I can see these clouds of dust. I think I can see it far more easily when I'm looking at this image, the blue image, than I can with the green image. I think the contrast between the red and green is obviously nowhere near as contrasty, if you see what I mean, as the red and blue, because they're separated from the spectrum so much. So I just think what I did was I just unscrewed my camera and I put a SIRL filter on it. See what I'm doing there? And I applied a filter so I could have a better view of my object. And I think it is a better view. That's really quite nice. except for me messing around with moving between desktops, of course, which we'll now move back into here. Now, obviously, what you do in the privacy of your own observatory is completely up to you, but some communities obviously have rules about processing images, and that would be that would break one of their community rules, maybe, in which case you obviously wouldn't post an image like that up onto their forum. You'd post the original image, which was here. But I think it's legitimate to use. If we're using electronic assisted astronomy, then I think it's legitimate if we're doing real-time-ish viewing, that why can't I just now and again just process an image to improve its view so I can observe it better, just as I would be putting a filter onto an eyepiece. That's the argument I'd make anyway. To be honest, I don't need to make an argument because it's up to me. But there you go. So we're up to 9 minutes 40 now. And it's really starting to show why it's such a great EAA object. Though obviously the first object I ever saw was M42. And that is an object. That's unbelievable object. I couldn't believe that was my first image. To see the best first of all was quite extraordinary. Anyway, we're up to 10 minutes, so let's log that image again.
Observation for M27 appended.
Excellent. And what I'm going to do is that after this session I'm going to go back, I'm going to grab hold of that process image that I just did, and I'll throw it into the observation log as well. But for now, let's move on to a different type of object. Let's move on to a globular cluster. M92. And M92 is in Hercules. And it's kind of left out because there's M13, which is obviously the crowd pleaser. Then there's M92, but M92 is a nice globular, as hopefully we can see.
Viewing completed.
Excellent. Let's move it up a little bit. And across. Now we're at, what are we at in terms of, we're at 62 degrees. Move it up a little bit more. It's just I like it being towards the centre. We're on M92, it's 27,000 light years away, let's capture it. So during this entire session we're just using 4-second subs, we're not changing it at all. What I might do is, after we finish, go back and do some 8-second work on M16 and M17 just to see if that gives me anything. Oh, we've got our same problem again, so if I clear it and then it's second time round it works. How strange. There we go. Nice. My FWHM is still quite low, so I'm going to move that down a bit more, the filter, and that way if it exceeds that, then obviously it will get rid of that frame. And there is our globular cluster. Let's zoom right in straight away. So there it is. Lots of noise, but as we wait, and this is the beauty obviously of electronic assisted astronomy, is that the noise is going to start going away, falling away, and the signal will come through. I almost wanted to go into some Firefly quote there about you can't block the signal mail or something, but I'll have to look that up. So M92, what have they got to say about this then? Discovered in 1777 by Johann Alert Bode. Oh, Bode's galaxy? Rings a bell. It's located 27,000 light years from Earth, we already know that. Containing roughly 330,000 stars. It's a lovely shape to this one, that's the reason I like it. I said everyone goes for M13, but I think M92 is a nice cluster. In fact, if M13 wasn't in Hercules, then wow, everyone will come to this one. So It's old because we know from previous observation sessions that globular clusters are old, but this is one of the oldest, and its predominant elements are still just hydrogen and helium, with only traces of some other elements, or metals as astronomers call it, so it's metal poor. But we've discussed globular clusters before as maybe the cause of dwarf galaxies that were captured by our much larger galaxy and effectively get ripped apart by the gravitational tide. These obviously guys circle in and out of our disk and lose their mass. So we're still, let me just change that shape to 2 again, make it a little bit brighter, and pull it out a little bit. And when I do that, it not too far. I just want to balance between, trying to balance between noise and the actual view. So you can see there's some different colour shapes. It has got a greenish tinge to it. I could filter it in SIRL, couldn't I? But I won't, shall I? I will, maybe in a minute. But this is maybe aesthetics, you see. In the other one, I thought it was so I could see more. This is maybe aesthetics, but why can't a pleasing view come into EAA? I can see this kind of multitude, this haze all the way around of these smaller stars. Let's take the colour down a bit. Oh, not too far. And let's just come out a bit. Give us some context. Wow. M92. So here's the image in Stellarium. Let's go DSS. Yeah, that's a better image. And the pan-stars image. Oh, got to get rid of DSS if I do pan-stars. No, I prefer the DSS image. Looks like we've got some artifacts from the survey there. So that star there is that star there, and there's a little double star there, and that's that star right there. So there you go. So we've had a look at a few objects today. We looked first of all at some nebula in the heart of our galaxy, star-forming regions, big clouds of dust and gas, multitudes of stars being formed. We then looked at M11, my favourite open cluster, which is the most distant cluster you can see with the naked eye. Well, how about that? And then we moved up to M27. We looked at the Dunbar Nebula, and there we also looked at V571 Vulpecula, which is the Goldilocks variable star, and we measured its brightness and plotted it on our graph, and that's an ongoing project. And we also then used SIRL to be our little filter, so that we could filter off that green. And in fact, there's no reason why, if we're doing that, because I sometimes find that the controls inside SharpCap don't give me the image I want, but I can just easily just go into here. Maybe I bring the shadows all the way down, bring the brightness up of my object, a bit more exposure, saturation. Oh, maybe about there. Warmth down or warmth? Warmth. No, about where it was actually. Let's save that as a copy. Yeah, I'll replace it. And there you go. I think that is even better, because that's really brought out the clouds now. The contrast is even more between them. So yeah, many ways of doing astronomy. We're on 4 minutes 20. Let's go back out to 100%. That's a lovely, rich little globular cluster. So we've done a few things. I hope you enjoyed it. I think Electronic Assisted Astronomy is the bee's knees. Definitely worth pursuing it, and if you haven't started, I'd start doing it. And remember, you can just do it the way you want to do it. It's up to you. Anyway, thank you very much. Goodbye.